The only thing I try to do, I was having a quick look at the vocabulary of BERT and other models and how it relates to instruments. And so the first thing was taking a data set of instruments, and we can have a look at it. It's quick and dirty, and I'm not sure that makes too much sense so far. One would have to do more on the quality of the data set. So there's a first question on like whether we should approach the dataset team to see whether we get a decent data set on real like instruments that really work. But for what I've done here, so this is the data set, and this is what I used, and there's a notebook which I use to just explore the vocabulary of BERT and other neural nets. And just a very quick summary is that roughly 10 to 20% of the instruments in the data set I collected were in the vocabulary, which is not bad, I think, because if we look at the instruments that are not found, they are really quite strange. I don't know any of those, essentially. On the other hand, some of the words I'm not quite sure why French or family is not in the vocabulary, so that there seems to be something, maybe there's still something wrong. But clearly the instruments that were found, these are, I guess, more or less useful instruments at that. I mean, it's really just, I don't trust the numbers yet, but this is sort of a quick overview, and we find quite a few interesting instruments in here. The most usual ones they are in, and other ones to really say how many we have and which proportion of instruments that we want do we actually have in these models. For that, we would need a good data set, and that's not yet here.
Okay. Hi, Oliver.
Everyone, I'm sorry that I'm late. I had to do a little more work, and the call had taken a little bit more time.
So now we have to treat us something. Oliver has to treat us something. We had some deal, right?
Can you repeat that? I cannot.
So
really,
in the last meeting, I think you have mentioned whoever comes late, they should treat us.
Yeah, you all get. So I will send some. I will send you some cake. Everyone who has played Portal knows what that means.
Yeah.
You're slightly at low voice. Can you tune, like, I don't know, make it more louder?
Just a second. I will readjust something. It should be better. I hope. Can you hear me?
Yeah, it's okay. Yeah.
It's okay. Not better?
Lightly. I just tune. I just increase the volume here. It's fine.
Yeah. Maybe it is switched on the wrong microphone. I can turn the wrong microphone.
No, it's fine. It's okay.
Okay. So what? Okay.
Yeah. So Oliver, just to very quickly recap, I just did a very small presentation.
Yes.
That works. Do you see my screen, my slides?
Yes, I see.
Yeah, right. So this is it's not much. Just saying. I was looking into BERT's vocabulary and its number of instruments that there are. And for that, to do it properly, we would need a data set of instruments. And the question is whether we want to approach the data set team for that, whether they have something or whether we want to like do it. And essentially, it's like roughly 164 instruments were found. It's roughly 20% of the ones I have in my list. But if you look at the instruments that were not found, these are really strange instruments. They exist, but some of them at least exist, but they are quite exotic. And
wait a second. I just wanted to overflow this. If you can. Yeah. Okay, Alphorn I do know. Kazoo I do know.
Yeah.
But it's like There's one I know, there's the second I know, but there are really...
The
Okay,
the alt horn should be there. That's strange.
Yeah, so what is quite important, like woodwind should be recognized. It's not an instrument as such, but it's an instrument group.
Right. Right. So exactly, that's the kind of stuff that I have not cleaned up properly. These,
yeah. But why should Scottish be an instrument or not?
Because it's the first word of a Scottish windpipe, or I don't know, whatever it was.
Ah,
and I did not carefully pre-process the data set. I just took the first word of whatever I scraped from the.
But maybe this is important. This is a very important information that to describe instruments, we cannot rely on only using one word. Like I see there also the word French, and this is most likely because French horn is a very popular instrument.
But it's not clear why French is not in the vocabulary of Bert. That to me seems strange. Maybe it's the capitalization that makes a problem. Could be that.
Yeah, it most likely is the capitalization because Bert is not able to distinguish between capital letters and small letters are totally different for the Bert.
Okay. So I'll redo that evaluation then. But just to see if we go to the ones that were found, they as we said, some of them are just the first word of a longer one. But on the other hand, I believe the basic instruments are there, but not terribly much more.
Yeah. So what I already see, having a blick glance. So they are mixed instruments and also descriptions of sounds like where was it? Sci-fi, plucked, baroque. So from a musician's standpoint of view, it is quite important to distinguish between the quality of the sound and the instrument as itself. But still, this looks really good. Okay, there's a couple of numbers, but I think we can filter out the numbers. No, we cannot, especially because there are instruments like the 4-string guitar or 6-string guitar.
But I guess the tokenization is the important stage that is missed, right? So we need a tokenization that makes sense for instruments, and that's not the word tokenization.
Yeah, actually, we can use like word tokenization, but we have to check if we can maybe come on, how to tell? We have to find out first if it's only a single word, if it's a noun. And I'm not really comfortable with this rule-based approach. I think it would be better than like continue like you already did. Because that you got this as a result is really not bad, actually. I think it's quite good. And when we have both routes with the rule-based and the only machine learned, I think we can we maybe combine later on both results, like getting the word embedding to find similar words and use the tokenization and the Vorverarbeitung, or what's the word?
Pre-processing.
Pre-processing, thank you. Yeah,
okay. So what would be the goal of such a task? I guess some sort of clustering of instruments, or like, of course we can take, I don't know, we can take a sentence the harpsichord is playing, and then just find all these sentences, I don't know, for all possible instruments, and then see which ones are closer and which ones are less close. I don't know where we're going from there, but if we really want to take like BERT's word embeddings as a basis for the like word embedding that we're going to take for the instruments, I'm not sure that, I mean, maybe there are better models. Maybe we take what was this this classification scheme of instruments that we recently heard of. Maybe we better take something like that. Could also be, I have no clue, but I'm not convinced that text-based, I don't know, similarities are best, but we can try.
Yeah, so what would be great is that if we can achieve such a word embedding that
similarly sounding words or instruments are clustered together.
Yes. So this would be ideally. Yeah. And what would be also nice is that instrument fitting instrument descriptions, which are often used with instrument, are also relatively close to the
right
fitting instrument.
And of course, the other approach would be to find music samples of those instruments and compare those.
Yes.
So if there's a database of just one sound from one instrument, and we can look at the spectrograms and take a similarity there, that would of course be, I don't know, a more principled approach.
Yeah, if we look at the sentence BERT, for that they'll define the loss function taking a difference between the two sentences.
Yes.
So for that it will be much more help, I guess, if we find these similar sentences, and that's how we can define a loss function for the sentence BERT and train it.
By the way, when we are talking about this right now, is somebody recording this?
Yes, I am recording it.
Great, Manoj.
Yeah.
I'm not quite sure whether if instruments are used in the same sentences, whether that really means they sound the same. So I'm not convinced that BERT is going to provide good embeddings for our task.
It doesn't need to be in the same sentence. So I wouldn't. It would be already helpful that like they are used in the same document. And I think one thing what the advantage is over BERT is over Word2Vec is that Word2Vec you have to give a certain window size, which is the maximum number of words which is between the word pairs.
And in BERT, you think it's just a bigger window, right? Because of the two sentences that are compared and so on.
It's not actually a fixed window, but in BERT you have actually for every word, as far as I understood it. I have to admit, I still not fully grasp BERT. I only learned it a bit theoretically. So like in BERT, for each word, it is computed the similarities over the whole document. And then the variant is taken.
Yeah.
But I'm not 100% sure if it's that the case with BERT, or maybe it's one of those many other Sesame Street variants.
Mm-hmm.
But the output of the BERT is a constant. The dimension of the output vector is constant. So for that we use the mean pool.
Yeah, sure. I just remember that one of the tasks BERT is trained on is whether a sentence is the next sentence of the previous one. So a two sentence go in, and the loss function is computed on whether they are adjacent sentences in a text or not. And I don't remember the second task. Maybe it's just the next word, predicting the next word. I think these are the two tasks. But Does anyone have a better understanding?
So, I haven't seen yet good examples of BERT over several sentences. I've seen it on within sentences for translation tasks.
Yeah, right.
And there, the relation between every possible relation is thought, and within those sentences, all words had been taken into context.
Yeah, BERT is a sentence embedding task and not a word embedding.
As far as I understand about the sentence BERT is that it takes the input, it takes the two sentences. It doesn't consider the what is the sentence used before it. Because if you look at the training of the BERT, sentence BERT, it takes the two inputs and with the probability score as well. Suppose if the two sentences are much closer, they have the high probability score.
Are you sure about the two sentence thing? Because as far as I understand it, you give as an input a whole document, and can be that maybe it's split up into sentences, pairs of sentences. But I do believe that as an input, we give a whole user input or a whole user text. And then BERT does something, and we get the word embeddings of every word of this document.
Yes,
Okay.
I can share my screen.
Yeah.
Oh, give me a second.
By the way, while the screen sharing is building up, I have a bad organizational news that Alex Gu has left the team because he doesn't have enough time committing to his studies and doing the project as well.
Okay. Yeah.
So yeah, about the training data about the sentence BERT, they give the two sentences, like my first sentence, my second sentence, along with the probability score. So here they
I cannot see the screen yet. Can you all see it?
No.
Oh, not yet.
Actually, one thing I thought about is like maybe we do the next team meetings with Google Meet ups, because screen sharing work much better than in Discord. What do you think?
Yeah.
But please tell us again. Share the link before the meeting.
Yeah, sure.
Yeah, of course.
So can you see my screen now?
Yes.
So if you see,
thank you.
Yes. So,
yeah, exactly.
Yeah, if you see here, like my first sentence, my second sentence, and the probability, how close they are. So this is how the input it takes in.
Yeah. So what is the train exam?
The label I don't understand, but
yeah, actually I think I do understand. So
label means how close the two sentences are. My first sentence and my second sentence are much more closer. That has high probability of 0.8. But if you see the another example, another pair and unrelated sentences, they are much more far. That is why the probability is only 0.3.
Okay, but what we really have to think about, this is only usage during training.
Yes.
Like because we have the label, so later on we can check the vector distance. This is the label between sentences.
This is, I think, only for the training. Once it has been trained, it directly generates the output vector embeddings.
Yes.
Yeah.
So for
So
that,
actually, also what I think is this is supervised training. This is not unsupervised training.
yes.
There's give me a break here.
Well, I would disagree, but I understand.
No, please disagree because I'm not 100% sure.
No, word embeddings are, you don't, all you have is the text. What you can of course make up fake supervised tasks like is this the next sentence to the previous one or not, but that's just a label that is very easily computable. It's not, you never have to hand label text to train any of these word embeddings.
Yeah, but this is exactly what I mean. Here it is hand labeled. What I am familiar within Word2Vec is more like you feed the training algorithm whole documents and it's counting the co-occurrence.
Exactly.
Yeah.
You don't need a label for that. You don't have to hand label text. You just scrape the internet and then you learn the probability of the next word given the previous few words, or maybe the word in the middle given the words before and after.
Yeah, I want to argue a little bit about it. Actually, we are taking it two sentences and giving the probability of how close they are. So it's actually the label, right? So it's kind of supervised, right?
But how,
I don't know. I'm just this is my understanding. So if you have
what do you think is point 8, that they are overlapping or like?
So in the vector space, they are much closer. These two sentences. My first sentence and my second sentences.
So the vector space is the one we're trying to obtain, to learn. We cannot use it to provide a label in the training.
I mean, label in the sense the interpretation is here is different. So interpretation in the vector space means how close these two vectors are.
Yes.
But actual, I mean, if you consider about the image, it is different. The meaning of label is different. But in this context, label actually defines how the two vectors are defined, how far they are, how close they are. So for that one will help the BERT model to adjust, I guess.
I think you can train BERT in different ways. And one of these ways, it's the one that Manoj showed. But I think in the original paper, they trained it like masking certain words and having BERT to trying to identify those words or something like that. So maybe there are I'm kind of sure that there are multiple ways to train BERT, and the one with the distance between two sentences is just one of those. So maybe there are like simpler ways to train it.
Yeah.
Yeah, I also heard about this training method with the masking.
Yeah, yeah. So that's what it is. It is one task is predicting a missing word, and the other task is like predicting whether it's the next sentence of the previous one or not.
Okay.
That's So we agreed there, but to get back to our task, I just, does that help us in any way? Like, the point is we have to figure out whether, I don't know, banjo is a word that has a reasonable embedding for us to relate it to its sound somehow. And I wonder whether it's not just better to have music examples and try to relate them there.
Now looking from the whole project view, what is quite important for the other groups that we still keep as modular as possible. And one, I would say, wish or desire is to keep our part as much text-based as possible. Yes. Because therefore it could also be used then to yeah, if we have other sources for the user input, that we can use our text-based analysis and informations on different input sources as well, and not only the input we get from the speech-to-text group. This was the wish. If we find out, however, that it's not possible, then we'll tell it.
Okay.
So,
but what if we take the text and we associate to the text like things, I don't know, labels that are based on sound? For example, I don't know, all of the things that sound in a certain in the certain way, the way A gets associated to these instruments, and all of the things that sound the way B gets associated with these other instruments. In this way, we would still take as input text, but we could try to cluster these text within respect to how they sound, the instruments within this word sound. I don't know if I was clear.
I think I have. I will repeat it in my own words, because I think I like the idea. So we get our text inputs. We check up a database. If we can find the instrument which we find in our text input, get musical informations from the database, for example, Freesound.
Yeah.
And therefore, we use those musical information.
What is that musical information? Like
like in audio, an audio sound.
Audio sample. Okay, yes.
So, like, for example, if we have a text about guitar, we look up Freesound for guitar, use those musical informations for guitar to give a vector to our text.
mm-hmm.
And then we say, hey, we have analyzed the text.
Yeah.
And it feels a little bit like cheating in a good way.
Okay, so let me really say that in a way less cheaty.
No, it's okay. It's okay.
No, because that's a little different idea. So let's take the idea of distance that Manoj showed before. Okay. So if we are able to, I don't know, determine a distance between two sample sounds, okay? And we find those samples with our keywords, with our text, then we could use that distance to train our text model, for example.
Yes.
Yeah, that is very... okay, now I get you.
Yeah.
Yeah, the kind of approach, like to borrow information from the audio, but without using audio.
This is a great...
Sorry, then I haven't understood it. So you don't want to use an audio sample to make it a similarity measure or whatever, to use it, but something else?
No, it is. We borrow the audio information for a whole lot of instruments. We use those audio information to calculate distance, and then we use those calculated distance by audio information to retrain our BERT model, so that the words get the distances which we acquired via the audio information. Is this correct?
So
that was one of the ideas.
So basically, it's like we don't even need the label here, rather than get the information directly from the audio, right?
No. We would calculate the label with the audio first.
Yes, what I meant was here it is explicitly given. Label is 0.08 because we know it. But
Yes.
what he said
Yes.
is that we will extract from the audio itself.
Yes.
Okay, yeah.
So we could still use we could make an automated variant of this label. So instead of giving here a fixed number, we will input a function.
Why do we need a label?
This is just for the retraining. So yeah, there's the instruments. That is just the distance between sentences for the training, as far as I understand it.
Why do you want to retrain BERT?
Because I want those information about the similarity of instruments. This is an important thing. This is important thing we would want to get out of our about our instruments text-wise. We want to have similar sounding instruments very close together. So that similar.
For that, you just take the spectrogram and you compare those.
Good.
You need
Then
BERT.
we have a simple way to do it.
Yeah. So we do
I
not
suppose.
actually. I don't think we need BERT.
That's what I'm
Like-
saying.
Yeah. Okay.
Well-
We still need some for word embedding. We would still need some kind of embedding. We could do it with Word2Vec as well. And
Good.
as a metric, we will take the audio similarity.
So what I understand, like if you have a sentence and you have an instrument, then you want to understand the meaning of the sentence, like give me a hard rushing whatever, I don't care what it is, and then comes an instrument. And we have these two features, and the one we might extract from BERT, I don't know, that is plausible to me, and the other one is just the instrument. We need a vector for that represents the spectrum or the sound of the instrument.
Yeah. So we will from our text we still need to recognize the instruments. And I had today a small discussion with the musician group. That it could be that instruments are described in a way without concretely telling the instrument, but describing the features of the instrument. Like, I just check if I found it. The concrete. It was like, I want a pitch shifted chorus sound.
Chorus is an instrument.
Yeah, chorus is also a musical effect.
Oh.
Yeah. Cool.
So this is the important thing. Like a chorus, it's like if multiple instruments playing at the same time. And they have a phase
Voice,
shift.
you mean, or what? The chorus is many voices singing together, right?
Yeah, this is the problem. It's not clearly defined because it's not.
Yeah.
Oh, I'm sorry.
It's if you have many people sing, it's the choir.
That's a choir, not a chorus. Okay,
Yeah.
yes.
I think
What's
it
a
depends on the position of chorus in the sentence. Where does it
Yeah.
come from?
Hmm?
I mean, the chorus, it has two meanings, right? Depend on the context.
Can we take another example? I don't know that word.
Oh,
I will-
chorus. I will just send you. Maybe I just find quickly a link with an
Choir,
chorus.
same.
Chorus choir.
Yeah.
So I know most, but
Yeah,
chorus.
I think you could like obtain a chorus effect with a synth, for example, with a synthesizer.
Oh.
Okay. So now see it. So like a choir can be a chorus, but a chorus does not have to be a choir. So like a choir is a chorus applied on the human voice, but you can of course apply it.
Yes.
You can apply it also on different instruments.
Here I
That-
read the chorus is a signal delay by 20 to 40 milliseconds. And of course, you can play any instrument you want. And if people don't sing together precisely, then from one voice you get a chorus if you just smear them a bit, I guess.
Yeah, so this is the easiest way to implement it. You can also, in reality, to make it sound awesome, you would not make it a fixed delay, but
I don't care. Yes, of course.
Yeah, but yeah, you are exactly right. It's kind of a small delay.
But the real point is whether when you say chorus, whether you already know most of how it sounds like. If that would be the case, then we have an instrument that's called chorus essentially. But if it's a transform on another instrument, and it still sounds mostly like many instruments, a chorus of flutes, I don't know, sounds like many flutes playing together, then the flute sound would be the basis that we should pass on, right? And it's still roughly a flute playing, but it's a chorus of flutes, I guess. And then we would have to figure out the flute part and not just the chorus. So the most of the sound would be generated by a flute example and not by a chorus example.
Yes.
And then we have like hard or soft or low or whatever, exciting, all these adjectives, which probably also make up a different description of the sound. And that one, I think BERT would be a good idea to use for encoding that information.
But then how do you encode it? I mean, you have a vector. So how do you extract this information from that vector?
Which information?
I don't know, the like hard or soft, the instrument, chorus, and these kind of things.
I mean, just to have a talking point, I would suggest we take a BERT embedding of the whole sentence, which hopefully says something about what the description is. And then we tag the words that are instruments, and we take some embedding of how these instruments sound and concatenate these two together. And then we have a few vector embedding dimensions that describe the sound itself and its quality, and another part which describes how the sound is maybe distorted or like high pitched or whatever. These type of descriptions of the sound would be provided by the second part.
Yeah. Sorry.
Yeah, about that part, what I did was I generated the vectors for all the sentences. You can see my screen, right?
Yes.
Yeah, so suppose we have sentence, give me a bright guitar, I would like a sharp cello. So I generated 748 dimensional output vectors and I plotted it and see how that happens. You see the first one.
Variation of what?
Sorry?
Yeah.
Variation of what?
Sorry, I didn't understand.
What is the quantity of which you take the variance here?
So this is the 768 dimensional vector. So I'm plotting histogram of that vector. How the different
of the embedding?
Yeah, of the embedding, yes.
Oh.
768. So how if you change the different sentences, how the standard deviation and mean varies. But mean remains almost constant, but only we can see the standard deviations changes.
Sorry, you take the standard deviation and the mean of the
embeddings
of the 768 or whatever embedding values.
Yes.
Coordinates.
Yes. You can
okay.
see on the downside, on the x-axis you can see all the data points, and y-axis how many times that point get repeated.
I think you should take a principal component analysis.
Yeah, I mean,
because the absolute values of the coordinate they don't mean much.
Yeah. I mean, that's true. We can try it out while reducing the dimension, how the histogram might change. So we can get some information that if we change the sentences.
If you could, first of all, how many principal components are necessary? Like maybe 700 is living in a much smaller sub manifold.
No,
Maybe
768 is the actual dimension. We can reduce the embedding from 768 to how much ever the lower dimension we want.
Yes, possibly,
Yeah.
possibly. Although BERT shouldn't allow that in a general case.
Yes, but in BERT also we can mention how many output dimension we want. But how different is it from reducing using a PDA? We can try it out, I guess.
Yeah,
You know what?
actually,
There's just a question. If we take BERT, if you look at the embeddings generated by texts that contain musical instruments and texts that do not contain musical or are not music related, and we should find the dimensions in which musical information is encoded by essentially taking the difference between like the principal component of variance in the non-musical texts and of the musical texts.
So a simple, so a kind of classification. We classify all words,
all dimensions. The 768 of those dimensions, there will be principal components there that are responsible for what we see in musical text, different that contain the difference from musical text and other texts. So general text use all the dimensions, I guess, but musical text in particular will use certain dimensions more than others, than other texts, I would guess. And so this way we might be able to find out which dimensions are music related, if that we need, or if that's useful.
Yeah, that's true.
Yeah, my question is if we actually need to do it like this way, or if it would be easier to just use a tool like spaCy to just feed it with instrument words and use that to identify the instruments. And of course, when we are feeding spaCy with instrument words, we already know we have to we have to watch out about the
entity recognition
training structure.
Yeah, you mean to say spaCy itself will give us the entity present in a sentence?
Yes.
How?
Yeah, you can retrain the entity recognition. And
yeah, but then you need the data set which is labeled.
Yeah. How? Yeah, this is the thing. We can hope for a good data set. I just seen there is a wiki project musical instruments. I will just share the link. Maybe there's a scrapable. I just shared in the Slack group. Okay.
Sorry to interrupt, Oliver. We have 5 minutes. At 6 o'clock, our meeting starts with the coordinator meetings.
First, Jane just wrote, "Are we having a meeting now, Ari?" Yes, unfortunately.
Oh, I had something to share actually.
I have some more time if you want.
Yeah, maybe. I think Manos, we can do it like last time.
Yeah, sure.
That I switched to the coordinators meeting, and because at the moment I can say on my part I haven't achieved much this week because I had a lot to do in work.
Okay.
And I think we did a lot of experiments, which is very good, and have checked out principal usage of BERT. The way is still not 100% clear.
Yes.
Yeah.
I will stay here. You will go to the coordinators, right? Meeting.
I go now to the coordinators, and Mirko, if you can share it with Yasus, and I will look at the recording later on. Okay. Wait a second. I will just give Paras a quick call and tell him to join you. Okay. See you.
See you.
Bye.
Bye.
So I don't know if I interrupted someone before or if I can share.
Sure, please.
Yeah, please.
Okay. Okay. So also, are we waiting someone else? Like Oliver just said that he would call someone else. I didn't not understand that.
Paras
No, I
has
think
no. Posted in the group that are still having the meeting, so he's gonna reply him.
Okay.
We're gonna have it, but we're not sure he's gonna join or not. But
so
anyways, we can start.
Okay, so I will start from a topic that is related to what we said so far. And I'm trying to share my screen, which is, this is an idea which came up last week. And it was basically the idea of building a commands patterns dataset, which it's based on this approach, which I will show you briefly. It's based on this approach. Basically, you have patterns of sentences with tokens that you can replace with proper words. And so the idea was to build it such as like give me a adjective instrument would become give me a bright guitar, but adjective could vary in a very large set of adjectives and instruments as well. And so we could plug different patterns and different kinds of tokens. Like, for example, this has a chirping bird. Bird is an animal or object. And so with like, I don't know, 10 with 10 like kind of sentences, if they would have like two kinds of tokens with like 10 adjectives and 10 instruments, we would have, for example, 1,000 different sentences.
So this is for this is for generating the data set, right?
Yep, this was an idea that came up last week. So I was just I wanted to like keep it live.
Yeah.
And this will be useful for the next thing I will show you.
Yes. What he has suggested, I talked about in a coordinators meeting. So dataset team also going for the same approach. I mean, it is very helpful, I think, if we share this one with the dataset as well as the music generation. And if you see the music generation spreadsheet they have given, they're updating with the same thing. They are listing down all the instruments to replace the position of the adjectives and instruments, whatever the things. Yeah, I mean.
And so because we would have a automatically labeled dataset basically. Like for every sentence we would have which adjective is in it and which instrument is in it and so on.
The one thing we have to keep in mind is just that the structure of the sentences we use, that is going to be fixed. We have to be careful to also include sentences that like start with the adjective or maybe the instrument and then have the subjective and so on, right? So just that one, if you put in a structure and then you go and do artificial intelligence to learn the same structure, well, you will at best get the same structure that you had at the beginning. You won't learn more.
You are right, and I took that into account.
Okay.
And so the first step, this is just related to the data set, and then we will go into the models. when we divide this data into train, evaluation, and test, we would keep different patterns in train, evaluation, and test.
Interesting.
Like there is no pattern that is in both evaluation and test, or evaluation and train, and so on.
Yeah.
So this will basically help us to measure the model generalization.
So we are taking the balanced data set, right? I mean, balance between the train, evaluation, test. So the classes.
Yeah, we can split this like how we like.
Yeah.
But the important thing is that a pattern does not end up in both. Like it ends up in only one set.
Right.
Yeah.
So also let's for example use questions as well. If in the questions have a very different word order than statements, and if you say like if you test on questions, can you give me a such and such, or would a such and such be possible for you to give me, or like structures like that, then it's going to be much more realistic, I think, than just have give me like imperative plus object plus adjective or whatever. It's always
these are all examples of possible patterns, and these are really, really good.
Yeah. So are we? I mean, do you guys actually know what is the possible way we can frame a sentence? Suppose like give me a dash and dash. So in how many different way we can frame the same sentence? Can we take all those possibilities for our training data?
Like a brainstorming activity. Like I think that I don't know if the data set is already doing that, but basically it would be like trying to write as many sentences possible, and then identifying the spots in which we could insert tokens. Mm-hmm. And the more sentences we have, the more patterns we will end up with, and the more variety our
yes. And also we can ask the music generation what is the possible different way a person who is going to use this system going to use a particular command, and we can take all those into context and frame it.
But I think
I don't even see a problem if we define a formal language. You have to start with give me, that's just a start word, and then comes an adjective and then an instrument, for example. As a first task, people can understand that they have to say such a thing. The question is whether we generate interesting sounds with that sentence structure. And just allowing more variety at the expense of being precise. Maybe these musicians, they would like to know exactly what they can input, and then you have a formal sentence which has to start with give me, and then comes an adjective, and then they just try out the adjective and the noun that comes afterwards. I don't know.
Well, once we have this data set, we could just filter for certain patterns, so that we could start off simple and then maybe add patterns to generalize better.
Yeah.
But what would be the benefit of like being able to say any sentence that contains an adjective and a noun, and just giving that adjective and that noun? Like instead of saying a full sentence, what is the benefit of being able to say a sentence or asking a question or something like that, when essentially you can just get the information that you need to provide an adjective and a noun, and that's it, or an adjective and an instrument even?
Well, from our application perspective, there would be none. From the usability perspective, it would be cool. And also from the like paper perspective, I don't know. So this is basically a system that it is expandable. You can start with like even one pattern.
Sure.
And then add more patterns. I don't know.
Yeah. but the reviewer will ask the same question. What is the benefit of what is, I mean, it's just a fancy way of inputting things. The thing that is really going to be pre-processed and used later on is maybe just the adjective and the noun. I don't know whether what is the influence of asking a question on, can you give me something? Would that sound different than please give me, or would it sound different than, God damn it, give me something? Would there be a different sound coming out of it? Is that what we intend to, or is it just?
Okay, so I will ask another question to answer. So what is the point for the whole system to say things and not just type in it? Wouldn't it be easier to just type it and not do the part where we translate to text? Yes, it would. And but that would be like a simplification that would take away a part of the system.
Yes, it is
to an extent we could just give the adjective and the instrument directly to the sound generation group, and that's it, and our work is done.
And also I think what you said is generating from a speech to text, it's more kind of adding a more feature into a product. I mean, if you look at it as a product, like if you have the Google Home, so we can directly usability, yeah.
Usability is what is added by being able to speak instead of type, but I'm not quite sure what is the added usability of being able to formulate any type of sentence instead of just giving the adjective and an instrument, for example. There may be, I mean, you can just give, if we want to aim for being able to input any sentence and out comes a sound, that is of course possible. But if there's no clear relation between the sentence and the sound, then it's just as pointless as just giving an instrument and an adjective and the sound not sounding anything like that instrument or that adjective we provide, right? So there's probably a core idea that has to work, and then we can work on the usability of the system.
Sure.
But I agree. We could.
I think we can work that way. Like if we start from a single pattern or a couple of patterns, and then we expand from that.
And also we can see the embeddings generated, how different it is. Suppose if we say give me a bright guitar, otherwise instead that if we say please give me a bright guitar. So what is the difference in the embeddings? We can take that into perspective and design it accordingly. This is my understanding.
Yeah. I mean, I would be happy if a bright guitar actually sounds like a bright sound and sounds like a guitar.
Isn't that the work of the sound generation group?
Yeah.
I mean, we give them an embedding which actually has this information, and then they should.
If we really give that information, then it's fine, But if we give them a bird embedding, then maybe that information is completely obfuscated. Maybe it's no longer there.
Yeah, along with the embeddings, we are giving the entities present in a sentence.
Okay, yeah.
Bright and guitar.
So this is actually where this second idea comes in place. So the other idea that came up kind of last week, and then I just refined a little bit, was this one. So we give a sentence to an embedding model.
Yeah.
And this is a Word2Vec BERT. It's just one of the embedding models that we can find. And it can be pre-trained, or we can fine-tune it on a corpus, on a large corpus of text with contents related to music.
So,
and And we get a highly dimensional array, okay?
Yeah.
From this.
Yeah, you mean to say the pre-trained on the dataset which is most closely related to the music commands, right?
Yeah, exactly. Or like in general, this could be pre-trained on whatever.
But it is hard to find a model which is being trained on the commands, the music commands. I mean,
I know. That's where the second part comes in place, like this dimensionality reduction stuff.
Yeah. Okay.
So once we have this highly dimensional array, we try to reduce it. Like one of the things were to have a low dimensional array, but we can reduce it so that only the information that we care about comes out. And this is where I was thinking of using our pattern dataset. So,
sorry, where would you use it?
In the dimensionality reduction task.
Oh, okay.
So basically, in this array contains it should contain a lot of informations, like some informations that we care about, some informations that we do not care about.
Yeah.
And while this like the output of this should contain only the information that we care about the most. The informations that we care about the most are expressed in the commands patterns dataset, because we made this exactly for that specific reason. Like, we want to get this adjective, we want to get this instrument.
Yeah.
So we know those information are contained in this array,
right?
And we want to extract it.
Yes.
Right.
So how can we do it? We could like do a fully connected layer, and we may try to classify what's inside these sentences. We could try to use an autoencoder, and if we use an autoencoder, we could apply disentanglement, which basically tries to tie specific things to specific dimensions of the output array.
Yes.
Variational autoencoder could be an option, but I'm not sure how to extract the embedding from that, because you have two embeddings which are mean and variance, and then you get an embedding, but it's more complicated.
So for the autoencoder, what is the loss function?
So from the okay, so on the autoencoder, the loss function is basically the reconstruction function. This is the vanilla autoencoder.
Okay.
We could add other loss functions in order to disentangle the dimensions of the array. These loss functions are basically found in a couple of papers that we reviewed, and there are other examples online.
Okay.
So basically, there are additional functions that say, okay, these two dimensions must be highly related to only instruments.
Yeah.
And very low related to everything else, adjectives and so on. And so this is something you add during training.
Okay. Yeah.
And so basically, from this, we are extracting the information that we care about from this array that contains a lot of informations. And we should end up with the low dimensional array that basically the sound generation group needs. So this was the idea.
Yeah, this is exactly what the sound generation was expecting from us, I guess, along with the entities present in a sentence.
I think I like the idea. The point is, so you have like words that are give me and so on. The embeddings of those words, they constitute one way of how the high dimensional array is going to vary. And the permutation of the instruments and the adjectives is a different way in which this high dimensional array is going to vary. And by dimensionality reduction, especially if you like average out one part of those and just look at the other, for example, in this way you can disentangle these two variations or directions.
Yeah, that's another way that we could try to disentangle, to make disentanglement like even different from these two that we studied.
I'm
not, but does it work? I mean, so if you take different instruments and you get this high dimensional array, you get different vectors, and it's essentially if you average these out, you average out the dimensions in which the instruments that you inputted above, in which they mainly vary. You just get the average of those dimensions, right? And you keep the dimensions of the sentence structure essentially, or vice versa. You try to average out the sentence structure that you have in your command, and you try to be sensitive to the type of instrument that's still in there.
Okay, so this is something that we could try. In general, I wasn't thinking of like working directly on the dimensions of the highly dimensional array, like applying transformations on this. I was thinking of like getting for every sentence his dimensional array, and then for every sentence we know what's inside. So for example, we know if two sentences have the same instrument. And so we could train the autoencoder, for example, to recognize when in two sentences there is the same instrument. Okay?
Yeah.
And encode this information in one sub. Okay? So
that is the same as saying we just take the original sentences, keep the one instrument the same, and vary the rest, and look at the variance of how the high dimensional array varies when you change a specific type of input. No?
Think about it. I'm trying to figure that out. I think yes.
I think the main gist is the same, I think, what Beat has just said. But how we gonna do it, that we have to decide it yet, I guess.
Yeah, sure.
Okay, so this works for one aspect, okay? So for example,
let me try to formulate again. By permuting your instruments in the beginning, what you're doing is you move in the manifold of these high dimensional arrays of the sentences you have. You move in the sub manifold, in the surface in which instruments vary. And if you are able by the dimensionality reduction to get down to find a coordinate system within that submanifold, then you find those few coordinates that are important for just the instruments in general sentences. I think that's what you're proposing here.
Oh yeah. This is another way of saying and because I was thinking about like what you said, like if you only change the instrument and fix the rest of the sentence, you are basically moving through the manifold. But if you, for example, change another word in the sentence, and then you get another sentence, you fix everything in this other sentence, okay? And then you start changing the instrument again, you're still moving through the manifold, but maybe you're moving in a different region, okay?
Yeah.
So this dimensionality reduction should recognize the instrument or give a subspace where the instrument is recognized independently of the rest, and the rest is recognized independently from the instrument. That's what disentanglement is, basically.
Yes.
Yes.
Yes. The problem is that the same task is just very much easier if you just take the input sentence and look at whether that instrument word is in the sentence or not.
So this is, so if we have a single pattern or a couple of patterns, this is possible. When we begin to have a lot of patterns, that's where basically embedding models for like natural speech come into place.
But still, the instrument would be easy to figure out. You just do a text search in the input, right? You don't need the embeddings to figure out which instrument you have to play.
Okay, so in this case,
but the rest of the sentence, the expression of how this instrument should play, that part is interesting to look, because there we don't have an easy way to understand a sentence that's talking about soft thunders or whatever, or any description of the instrument and how it should play.
Okay, so how should like a data set that expresses a thunderous sound, okay, be labeled?
Yeah.
Because if we have labels, okay, we could just train the dimensionality reduction towards those labels, and we would be good.
even like, so the adjective and the noun, if we have those two, what else are we trying to accomplish? Because those two we can find by simple methods, right? I think, was it Alex who tried to do NLP on just finding an instrument and its adjective that is associated to it?
I think it's Shubham.
Okay, she's okay. If we have him, and if we figure out that part, then the question is, apart from that information that he gives us, that adjective and the instrument, what else do we want to learn in the sentence?
I think it's only that two entities which are more important, and I think that's it. I think for the sound generation we need to give, but for the training the autoencoder also we need that two part, I guess. If the
But like Mikko, like what you're doing here is by permuting these adjectives and the nouns, you're essentially placing the focus on the structure that is left when the instrument and the adjective does not matter. That is what I believe. What you get out by this dimensionality reduction, the dimensions that should come out there would be precisely those that are not depending on instruments or adjectives that you put in, because that's the ones that you just permute like randomly. And there could be interesting structure in there. I definitely.
Yeah, I mean, that's another way to look at the whole thing. I mean, for example, you could have two dimensions that basically express the instrument. And if you plot those, maybe you could like cluster instruments together. Okay.
Indeed. And the same for the adjectives.
Exactly, and the same for the rest. And you would have basically this array which is composed of these subgroups. These informations in the highly dimensional array are scrambled, are like meshed together, and this part basically also gives disentanglement other than dimensionality reduction.
Yes. Yeah. So what kind of information is that? For example, whether you are, I don't know, whether you formulate your request as a question, or whether you use strong words, or whether, I don't know, whether you are polite, for example. These kinds of variations in formulating the same wish for a certain sound, those would be still present in this in the low dimensional array, because you exchanged all the other elements and you randomly permuted them. That information is destroyed, and the remaining information, I'm not quite sure what it contains, what type of information that is, but it's definitely very different from the rest of the information, and it could be useful for sound generation.
I think we can simplify this. So the information that we can extract is basically every information that is given us as a label. Okay. For example, in the Commons pattern dataset, we know which instrument is in there, because this particular sentence is labeled with instrument guitar, for example.
Okay.
And an adjective is the same. Okay.
Yeah.
So let's say we want to add another information. For example, I don't know, if there are like opposite adjectives, for example, bright and dark, we want to give a 0 if there is bright and a 1 if it is dark, and so on for the other adjectives. Okay, so this should be a task for the dataset group or the music group. So basically, once they give us those informations, we can try to encode them in a disentangled way on a low dimensional array.
Mm-hmm. Yeah.
Mm-hmm.
So that part also discussed in the last coordinators meeting is like we need the annotation for each sentence. Suppose give me a bright guitar. What does give me a bright and guitar each word corresponds to? So we'll have that information, I guess, but we'll discuss that one with the dataset group as well.
So the grammatical information we can get, if it's just an adjective or a noun or a subject or maybe an adverb, that information, I guess, is not very hard to get. We don't need to someone label us that for us, right?
I don't know.
This is Shuram's task currently.
Yeah. I mean, if they give us the extra information, if we want to do it in the future for some part, I think we can use it, but it's no harm in just getting the information like for each word, I guess.
Say it again, please.
So what I was saying, like there is no harm in getting the information for what each word corresponds to, because at the later point, if you want, we can just use it at some case, we don't know.
Now, I think what Mirko is pointing out is what kind of information, how do we extract all the information that is not in the adjective and the instrument? because that's what he's by just permuting all adjectives and the instruments. You have noise in those two elements, and everything else that's in the sentence that is left in the highly dimensional array that comes out of this embedding model. And what kind of information that is, it can be highly important for, I don't know, for the expression of a person might, as I said, otherwise it's just a formal system that provides an adjective and a noun, and we do something with it. That's one possible way to do it. But if we want to use the rest of the information, then I think that's an interesting way to get at this information and get a low-dimensional embedding for what that information has, what that is.
Yeah.
Well, I think like sound generation or datasets group should like define which informations are actually valuable.
Yeah.
Yeah.
And the question really, to me, really is whether it's just an adjective and a noun, or if it's more.
So, for example, we could add another task to the training loss of like our fully connected layers or autoencoders. For example, if we take the example that we made before, we take the guitar, okay, and we take the sound of the guitar, we take another instrument, I don't know, the cello, and we take the sound of the cello. Yeah. We compute the distance from that, okay? So we could give the task to compute the distance between sentence that contains guitar and the sentence that contains cello, okay? Mm-hmm. To our dimensionality reduction training loss. Yeah. And that would be another task for it to solve. And so it should change the way it groups together. Yes. Things, yes. Instruments. This is an example. Like what I want to say is that labels could also come from the sound part. This doesn't mean that we need to use sound. Okay, we could use that information to produce a better embedding. Mm-hmm. Then this is something that I think we should say to the sound generation, because I think they know better what kinds of information could be extracted.
Yeah, it's true.
I really like the idea of using sound examples of known instruments to somehow define the similarity of these words.
Yeah.
Because in the end, it's not just words. It's really that entity that we. But then I think our task is well. Then we are very limited to just understanding those instrument names. If they appear, then we know precisely what it is, and we can tell the sound generation group to produce a cello-like sound, whatever. But if there's anything else, any other information in a text that is not just the instrument, or I mean, even the adjective is more complicated. We don't know what a dark cello sounds like. We would have to figure out. Apart from these two things, I don't know what else there is.
Okay, so let me think about this. One thing that we will inherit from an embedding model which is pre-trained or fine-tuned on a big corpus is basically that some similarities are already there. For example, an adjective as dark and another adjective as I don't know, black. Okay.
Yeah, exactly. Yeah.
They would be already close.
Are you sure? Have you tested that?
I did not test that, and
these are very nice stories that I hear all the time in the internet. Whenever I try it myself, I don't find it.
It's just a hypothesis which we need to do.
Yeah.
Yeah, but this is where the fine-tune part comes into place. Like we could hope that fine-tuning these models on our specific context would help in that sense.
Yes.
Like for sure we cannot extract this whole information from our pattern data set because it's
not there. Yeah.
Yes. Yeah. And so we need to borrow it from somewhere else, and I think this is the place.
Yeah.
Yeah.
And so given that information, I think we could try to distill the information that we need through the dimensionality reduction, starting from knowing what it's in the sentences, and then maybe later adding more patterns or more labels, like more informations to these sentences. This also becomes modular, like you can build up starting from simple.
Yes.
It should be also modular in the way that someone could train, embed, or find pre-trained embedding models, and someone else could work on dimensionality reduction. Like multiple people could work on this. Some could work on fully connected solutions, and other on autoencoders.
Yeah.
So
I think BAT has already started with the pre-trained model, I guess, right? So what I mean, from the presentation, what I have seen, you already look for some.
I mean, I just took BERT and took a pre-trained BERT and got the embeddings of it. That's where I am there. I don't have any understanding of what these embeddings are like, whether they are useful or how similarities of instruments or something are expressed in BERT. I don't know much. Yeah, this type of information that would be a task ahead.
Yeah, I mean, if you want to go into, I think you can take this topic and someone else can work on the dimensionality reduction and fully connected layers.
Yeah, sure.
So yeah, so you'll be working on embedding models, right? The pre-trained models. And
that's what I currently did.
Yeah, I mean, if you want to continue, I think you can choose any one topic so that I can also choose. I can work on the.
I mean, using the pre-trained model, I think definitely if we have such a pipeline, then we do have pre-trained models currently. What we don't have is a retraining procedure, but basically I don't think it makes much sense as long as we don't have data to retrain, right?
Yeah, I agree.
Yeah.
So I'm not quite sure at the moment what are the main productive ways to go forward. So we can use the pre-trained BERTs. I definitely agree there, but retraining I'm not yet sure.
I think we can explore that area, and if we find something useful, and we can make it ready until the data comes in. So at that point, I mean, it's no point of jumping into the generating the embedding once the data comes in, right? So we'll be prepared with it. So once it comes in, we start training.
Yeah. Yeah, right. Exactly. Yeah. And yeah.
So
we basically lack data.
Yeah.
We need data right now.
We're going to send more mails to dataset team.
But Mirko, that's why your approach is also quite interesting. Like if we understand certain types of sentences that make sense, and even just to try to extract the adjective and the instrument from that, that would be a useful first step, because whenever the data comes in, then we can pre-process it with that information and then start the retraining. And we have extracted some information already about the instrument and its adjectives. And then if other information is still in the sentence and we need to understand it using BERT, then that's already done.
So you are talking about like taking a sentence and like we try to extract the adjective and the instrument?
And that's sure, Ramo, that's doing that currently, right?
I did not understand.
We do have someone working on extracting the instruments and the adjectives.
Yes, I think Shubham is working on, but no updates from him now, because he is working on extracting the entities from a sentence. I think he shared the Jupyter notebook as well regarding that. And
yes,
we didn't get any updates, like it was not working for some kind of sentence, I guess. That was the problem with that.
Yeah.
But he had the old problem that basically the data set that he tried to retrain the extractor on was very little, and so his extractor would overfit.
Mm-hmm.
Yes.
Right?
Yes.
So this is where actually the Commons pattern data set, once we have a lot of patterns and a lot of keywords, could come in handy.
Yes.
Yes.
But in this regard, like once we have that, like we have the keywords because we made the data set with those keywords ourselves. So
but don't forget there might be instruments that we don't have yet. So we need that data set of all the instruments that there are, so that we don't like just ignore those words if they appear in the sentence.
I think it's the music generation team has already listed down the instruments. So I saw last meeting they are brainstorming and listing down all the instruments. We can look it out and we can use that.
And we don't need any other instruments than those.
Yes, they keep on updating it, but till now we can use whatever the things are there.
Okay.
Yeah.
I think there was a choice where there was basically like to focus on guitar related themes, because like the generation would be like very hard for any kind of instrument, and so there was this like focus reduction in order to keep things feasible. But I'm not sure, like I think I read that somewhere. So once we have like the list of all the instruments, and maybe a list of adjectives that can like make sense with those instruments, and some patterns, we could build this data set.
Also,
or a data set group could actually.
Yeah, I mean, it's
sorry.
Yeah, we can just tell him the approaches and we can ask for the data set.
The work of entity extraction could be used to find new patterns. Like if we train a keyword extractor with our common patterns dataset. And that keyword extractor is able to generalize to other patterns. We could use that on a corpus to find the new patterns to put into our dataset and expand it.
Yes.
Yeah.
Yes.
True.
Also, by the way, for the adjectives, I'm quite positive that a simple word2vec would work rather nicely, because if you think of it, adjectives that are similar, they are used in similar contexts of sentences, right? So if you have black and dark or something, they probably have the same word embedding because they are used in the same type of sentences. You have dark nights and black nights, whatever. So for the adjective, I believe we could just go for whenever a new adjective comes, we get its word embedding and find the word embedding that we know about in your patterns, say, that is closest, and then use that pattern.
But we would still need to find that adjective. Like we would analyze every single word.
No, that's easy. How do you mean? We have a list of adjectives that we know about and that are used for certain embeddings that have a specific meaning. And if a new adjective is close to one of those, then we use that word's word embedding.
Mm-hmm.
No?
I get that. I don't see how to fit this in like this approach, because this approach like takes a sentence and outputs an array, and you are talking about single words.
Yeah.
So I'm having a hard time figuring out how to put that in here.
At least for me, what you're showing here is interesting, not for the noun and the adjective, but not for the instrument and the adjective that comes with it, but for all the rest of the sentence. That's how I view it. Because if we have an instrument, then we know how it sounds. We just get a sound example of what it is. And for the adjective, well, we know what the adjective is like, and I guess, yeah, that. But the rest of the sentence there, I don't see how it impacts. But okay, maybe we're not yet clear about that.
I see. So basically, it is easy to accomplish a keyword extraction task. Okay.
At least that's what. If the command sentences come in the form of give me plus adjective plus noun, that's what I would focus on.
Okay. I see that. But then you have these keywords, and you have to give to the sound generation group an embedding.
Yes.
So we would embed these keywords. Is that what you think?
What I am suggesting, because I hope that word2vec has a similar word embedding for black and for dark, for example, or for bright and for white or something.
So you are suggesting don't take the entire sentence, but take only the important adjective and
because I cannot imagine how the type of sentences that we have depend on strongly on the part that is not the adjective and not the instrument. Yeah. I believe that the dependence on the rest of the sentence is minor, but I can be wrong there, definitely.
So basically, we are assuming that given the guitar, the instrument, and given the adjective, the context doesn't matter. Like we have all the information that we need.
I mean that let's state it provocatively like that, yes. And I would be interesting to hear someone disagree, or show examples on how like this could be a way of generating training sentences. How could you formulate instructions for the system that sound weirdly, very strongly different, but have the same instrument and the same adjective? Give me a sentence with soft and guitar, and formulate something with those two words that sounds in two very different ways. That's an interesting challenge, I think.
I think it's just a hypothesis. We don't know yet if it's gonna work or not. What we can do is that, yeah, we can generate generating the embedding using the BERT, as well as generating the embeddings using word2vec only for the instrument as well as the adjectives, and see which one will work.
Yeah, right. Exactly.
Yeah.
Exactly. No, and I agree there. So if we, in the end, we can compare the whatever complicated system you do, and you produce from a sentence, you produce an embedding vector in some complicated fashion, and we compare that output with the output of the sentence that contains only the noun and the adjective of the original sentence.
Yes.
And I personally would expect that those two should be similar. And if they are not, I would be interested to hear for a reason why the rest of the sentence makes for such a drastic change in the output vector. Because if it's not justifiable, then I don't see how we can use it. If the output embedding that we provide strongly depends on things that we don't understand why it should impact the sound generation, then how do we argue then?
Okay, so let me try to like make a similar approach to this, like for like a form similar to this. So we get a sentence, we basically apply entity extraction, and we get an instrument and its adjective, for example.
Yeah.
Given those, we embed the adjective and the instrument. We get like two embeddings. Okay.
We can try that out. We do have BERT.
Yeah. We can. I'm just trying to figure out the full pipeline.
Yeah. And then we compare the embeddings of the two sentences.
Okay. Once we have these two embeddings, let's say these are the embeddings that are good, like we trained the perfect model. Mm-hmm. We still need to do dimensionality reduction, I suppose. Right?
Yes. Or we have already done that. We can, we generate the low dimensional array both for the original sentence and just like, so what I would say is we take one of those sentences that you have, you give me plus adjective plus noun, that would be like our standard sentence. And we generate the low dimensional or high dimensional first and then the low dimensional array for this standard sentence. And then we compare it to all the other sentences that you generate by permuting, by taking those same adjective and noun and put it in different formulations of right? That's what you can do. You can just permute those. You take all the patterns that you have and you insert your adjective and your noun into it, and we get another high dimensional array, and from that another low dimensional array.
But this array should be the exact same array because the entity extraction part, which is the first thing you do, should extract always the same keywords, and those keywords would get embedded to the same.
So the embedding model that you have here only uses bright and guitar and not the rest of the sentence?
that's what I was thinking. Like, I am not okay. I am not talking about this thing.
Yeah, I
okay,
think that is the idea of dimensionality reduction, I guess. Finding the dimensionality reduction actually means finding the embeddings which actually defines the bright and guitar, rather than give me a bright guitar.
Now I'm confused.
Yeah, I think like saying that while looking at this like got you confused.
Okay, so I don't look at the slides anymore, okay? And I just listen to you, okay? Okay.
I'll try to say it again. So we get a sentence, okay, and we extract the entities on it.
Okay.
Which are guitar and bright, for example.
And we discard the rest.
Yeah.
Okay. Okay, then we're done. Yeah.
And we embed. We are not done yet because now we have text. Like we have two words. We still need to get an embedding.
Yeah.
So we embed those. Yes. And I think we get highly dimensional embeddings at that point. We still need to get low dimensional embeddings. Okay?
Yeah. Okay. Yeah.
So that's where I'm stuck. Like, so how do we do that?
Yeah. Yeah. My suggestion would be for the instrument, if there is an instrument as one of those sounds, then we take a similarity measure of the sound of how they sound like. And for the adjectives, indeed, there I don't know. There, I guess a word embedding would makes sense. And then it's everybody's guess what is the correct way to go forward, because the word embedding itself already did a dimension reduction. And maybe we should retrain on a big corpus and just have a lower dimensional word embedding. Maybe that's better than use PCA on top of a 128 dimensional word embedding.
Okay. So as I see it, it's still basically taking a highly dimensional array, applies some kind of task, maybe unsupervised, in order to get a low dimensional array. So I think this second part is used anyway. Like, we still need to do dimensionality reduction, and we still need to input a highly dimensional array and accomplish a task that is given from labels. Okay, so I think this block, like if we develop this block, we can reuse it in both the sentence embeddings or the word embeddings and the entity abstraction.
Yeah.
Okay.
True. We can check it out which one works well and use that.
Yep.
But what about training a word-to-vec embedding with less dimensions directly?
Can we do that? Because as far as my understanding, it gives a fixed, the dimension of the output vector, it's directly proportional to the length of the input sentence.
To the what?
Length of the input sentence.
No. In word2vec, it's a free variable.
Okay.
In word2vec, you actually have an autoencoder with a number of neurons in the middle, which gives the embedding dimension in the end, right?
I don't have much information on that, but
okay.
If we are able to fix a output dimension, yeah, we can try it out.
At least, yeah. So, yeah.
So the downside of this is that I don't know if in the second, I should make a diagram. In the second approach, which is where we extract the single words. I don't know if we could rely on the pre-trained models or like informations, like knowledge outside of our own words.
Yeah.
Because we would have a really small data set that way, because we are throwing away basically the pattern part.
Yeah, true. But we actually doesn't know if we throw out the not important part, how it will affect for generating the embeddings. What is the quality of generated embeddings? We can check it out, like if you actually look for the different patterns and try it out, how good the embedding is generated, and if you ignore that part, how well the embedding is being generated. I mean, it's too early to decide, like to actually ignore that part or not, right?
But how do you want to train a word2vec on just the adjective and the noun?
Yeah, that part, no, I don't have idea.
How does that work?
No, yeah, that does not work. You're right. Like word2vec is trained on a corpus, and then we would use it in prediction on single words.
Yes, that you can do.
That's how it should work. So basically, we should still need to train it on a larger corpus.
Yeah. So what I presented, what I would be interested in, if you do a clustering of instrument words in the say BERT embedding or word2vec embedding, do similar instruments, are they clustering together at least? Or do we have drums at the same end and string instrument at another end in the embedding space? Or is it completely, maybe we don't see anything, any such structure?
We can try it out. We can try the BERT as I plotted the histogram, right? We can plot for the two different instrument and see overlap one histogram over the other and see how similar they are.
So Mirko, we could take your sentences and keep the structure the same, but input string instruments in one end and drum instruments on the other end, and see how different the embeddings are, whether like the variance within the drum instruments is smaller than the variance overall the instruments, say. So the within cluster the variance should be smaller than the overall variance.
Yes.
If that is given, then I would have some confidence that we actually have some information on how what these instruments sound like.
Yeah.
Okay.
But if a string instrument is closer to a drum and whatever a trombone is closer to a flute than to all the other trombone type instruments, I would start worrying whether our approach works.
Yes, but one more thing I want to point out is that it also depends on what kind of data set we are trained on. Since the
Wikipedia for BERT, you don't have large enough data sets other than a few.
Well, that's why the dataset group is scraping the internet for putting together a corpus that talks about music.
Yeah. Okay.
So I think to achieve what you say, we should fine-tune a big model on that corpus, which specifically talks about music.
Yes.
Yeah. Yeah. Okay.
Agree.
But for example, you cannot insert new instruments into a BERT pre-trained model. There's no way.
Okay. Would be Like, is there the same problem with a word2vec?
I believe not. No.
Because you're embedding a word.
Exactly. And if you have new texts that have that word in it, then you can train a word embedding for that. Yeah. It's not the case, I think.
Well, but in the same way, if you have the text with that word in it, like the text is made of sentences, you could also retrain BERT. Like, does retraining allow you to expand the vocabulary?
No, in BERT, I don't think so.
Sure about that.
Yeah, it's a good question. No, because no, so Genzim, for example, what you do before, so you have the BERT model itself, and you always have a preprocessor, and they are associated to each other. So you need to pre-process whatever sentence you bring in the same way as the BERT model was pre-processed. So the pre-processing was done when training the BERT. So
that's for prediction, though. Like,
yeah.
Is it the same for training?
You always do a pre-processing before you start training, right? For example, you need to use the same tokenizer.
Yeah, and you also need to, like, if you really want to reuse the weights, you should link the same words to the same identifiers. Like in some, like in word2vec, for example, every word becomes a number, which in turn becomes a one-not vector, which in turn becomes an embedding.
Yes.
So you should keep that.
That number is depending on the vocabulary, and if your word is not in the vocabulary, essentially what you get is is one token, which is usually UNK, unknown, stands for unknown, and you get one word embedding for the unknown keyword. But every word that is not in the vocabulary is going to be mapped to that, so it's useless. If you have a new word, you need to adapt.
I cannot come with an idea in which you could actually add more.
That is a edge case, I guess. Now we can focus on the basic sentence what we have, then build upon it. Suppose what you said, like unknown and UK. So that is the most edge case, right? It's less likely to happen.
Less likely to happen when?
I mean, less likely that sentence will come, right? Like the unknown and UK. I mean, that's what I understood from UK and unknown, what you said before. It's like if the sentence comes in like give me unknown something or give me UK.
Exactly. If we have a sentence that has give me a vihuela, like a screeching vihuela, and vihuela is an instrument that is not in word2vec, then you will essentially input give me a screeching unknown. And the word embedding for unknown is some vector, but it's going to be the same for any instrument that is not being used so far.
Yeah, true.
So maybe we could start with only the instruments that are within the vocabulary of the model that we will use.
Yeah.
That could be
definitely
a simplification.
I mean, it doesn't make sense to use other instruments.
Okay. So the first thing,
we should try it out, I guess. So maybe you can generate a few sentences that have weird music instrument names, and then we take the BERT embedding and see what it gets. But I suspect that whatever weird music instrument you input, you will get the same word embedding out or a sentence embedding out.
Just give those to the preprocessing part and see if the unknown token comes out.
Yeah, right,
Yeah.
right, exactly. Yes, indeed. But what I've done, like if you want to see the notebook, you just go into the vocabulary that BERT has.
So we could just check there, like we have a list of instruments. If it's not there,
indeed, that's what I did.
Yeah. So okay. So to start off, we could start with just the words that are contained in the vocabulary. In order to expand the vocabulary, we should train from scratch, because we cannot fine-tune adding more words. In order to train from scratch, we would need a model which is like decently sized within respect the size of the data set that we are training on. This depends on what the evaluation group is able to extract from the web scraper. And once we have that new trained model, maybe we could add more keywords to the commands params dataset.
Here's another idea. We have I don't know, a BERT embedding of 700 or whatever dimensions. We chop off one of those dimensions. We just go with 763 dimensions, and the last one, we give it a value of 1 if the instrument is in the vocabulary and -1 if it's not in the vocabulary. And then we can do whatever we want with the remaining 763 dimensions if that word is not known by BERT. We can do any, I don't care what, but it's just a different situation.
But what does that achieve? Like, we already have that information from the preprocessing.
Yes.
And we have useful word embeddings for all the instrument that BERT knows. And for all the instrument that BERT does not know, we can input a new embedding that does something similar, like useful.
Adding 1, I think it has very less significance for the embeddings.
Why?
I mean, see, out of 764, if you take at least 1 dimensions, anyway, we are going for the further dimension reduction as well, right? I mean, it's just an idea. I'm not sure.
The point is, in the sound generation group, in whatever way they use that embedding to generate something new, that neural network can figure out which dimension has this difference, where there's a big difference in the structure of the data, and prime on that. If that value is -1, then it does something completely different than if it's +1.
So what you're saying is that we can give this information as an additional dimension of our array.
Exactly. It's just additional information. We did not know about this vector in the BERT sense, and we provided some other information instead.
We can do that programmatically. Like, this information doesn't need to be output to be an output from the neural network. We just make it.
We look up in the dictionary whether that word is in there, and if it's not, we do whatever we want. We take a different
this is something we can do. But I think that at this point it would be better to just add the information later and keep it like separated from the rest until the very last output.
Maybe the sound generation group is going to train different models on that value, right?
Yeah.
Or whatever.
And also, if you take the sound generation team, if you see their pipelines, apart from taking the embeddings, they also take all the entities present in a sentence. They directly input.
Which entities they take?
Entities we provide them.
Yeah, exactly.
Yeah.
And they're going to weight those entities in different ways, and the 700 dimensions of BERT, they are going to be very unimportant compared to whatever other qualitative information that we can provide.
Yeah.
I believe. I don't know.
Well, at this point, like our task would be just to abstract those entities. Like I don't see the point of making the embeddings if the entities already all the informations that they need.
Yeah, for example, we could take some the most usual instruments that we know of and only do something standard with those type of embeddings, and all the complicated instruments we just, I don't know, we don't do that. We just say that's an unknown instrument that's coming in, and maybe we have some adjectives that describe that. We replace that word by adjectives that we find in some data set that describes that instrument.
Then, okay. But then we could just train a model ourselves, like a word-to-vec ourselves.
Yeah.
On the data set that basically has the adjectives for that instrument, because it has the instrument and the adjectives. It's a corpus.
Yes. Yes. Yeah.
But in that case, we would have that like we would be able to recognize that instrument as an entity. So we could just give that entity to the sound generation group.
Yeah.
Like I don't see the point of producing the embedding.
So I don't know, maybe I thought of something completely different now, but if we have descriptions of those weird instruments, and then we don't need the vocabulary of 100,000 words that word2vec have. We have text that have probably a very limited type of description, but the diversity in number of instruments is much larger than in the general Wikipedia word2vec trained model. So a model that we train on text that is specifically geared towards these instruments, they might not know about stairs or about the weather or about, I don't know, whatever, houses and stuff, but they might know quite a lot about instruments and words describing sounds. So it could be that we need quite a small data set if we really focus on the relations that these adjectives have with respect to instruments and not to all other Wikipedia words that there are.
Oh, I see. Actually, so if we extract the entities, okay, we basically have, we know what we are talking about. We're talking about a guitar. We're talking about something else, okay, and adjectives too. But with the embedding, we have latent information about the relations between instruments.
Yes.
And so this is what could be useful to the sound generation group.
Yes.
Okay.
We get a much lower dimensional embedding that way, and it's very specific to the type of words that occur in musical texts.
So, okay, at this point, I still think that we would just need the embedding of the words.
Yes.
Unless, like, let's take a bright guitar, okay? And let's take a bright, I don't know, flute. Okay.
Yeah.
Are these very similar or very different? Like if we change bright into dark, okay, are they closer? If we change the instrument, are they more close or less close than changing into dark? Okay, so this kind of questions can be answered through the embeddings.
Or we can even say that's not our task, because the sound generation group is going to figure out how these descriptions are going to sound. But we provide all the relevant information, namely bright and flute.
To answer this question, I'm trying to figure out if our embedding can hold this latent information. Okay.
Which information? About what?
About the relation between the instruments and the relations between the instruments and their adjectives.
You think instruments have adjectives? Can we not use any bright? Can we not use the adjective bright for any instrument? And vice versa, can we not use any adjective for any instrument? I mean, they're not related.
Yeah, they are not related, but I think that saying bright guitar and saying bright flute could have different different things, like a different outcome.
Yeah, sure, but that's what I'm saying. That's the worry of the sound generation group.
Okay.
How this has to sound, that's sound generation. We provide the information that the adjective bright and the adjective flute is, or the noun flute is relevant in this text.
Okay, I see.
And maybe we provide information that, I don't know, a didgeridoo, which maybe we don't know in our vocabulary, sounds similar to an alphorn or whatever. And then we should have a word embedding that is closely related to, you know, the word embedding should not be too far off if the instrument is, I don't know.
Like the relationship between words should be exploited by the sound generation group.
Yes.
Right?
Yes.
Because we have the instruments that allow us to exploit this. Because we work with text semantics.
The sound generation group will be grateful if we find word embeddings where similarly sounding instruments are close together.
And
so this can be.
I asked this question like, do they actually need the reduced dimensional output vector? But what he was saying, like they don't expect specifically reduced dimensioned output vector embeddings. I mean, it's fine if you give us the full dimension output or the reduced dimensional output.
Both is fine, you're saying?
Yes. I asked this question specifically last time.
Yeah. So we could avoid the disentanglement altogether.
Yes, but it's a good option to try it out. I mean, if it makes a difference, we don't know yet.
But I mean, we could just assign random vectors. If that doesn't matter at all, then why do the work? I believe we are trying to use text to assign meaningful embeddings that try to somehow encode the information that we have about these instruments and these adjectives in a way that simplifies the task for the sound generation group.
Exactly. But we don't know if we reduce the dimension how well it's gonna affect. We don't know yet, right? I mean, they're just hypothesizing it. They don't know exactly how it's the system gonna behave.
Yeah. I mean, we can even by I don't know. Do you know this example of these embeddings? If you project them into a linear plane, then you can destroy much of the information that you have. So we can also do quite bad things if we reduce the dimension too much.
Well, if it does the dimension, you are losing information. Like you're basically doing a compression.
Exactly. Do you see my screen?
Yeah. Oh, I am still transmitting.
Yes.
Okay.
What about now?
Okay,
Yes.
I see it now.
Yes.
You see my screen?
Yes.
So this is this famous example, right? Where if you have S-shaped submanifold, two-dimensional submanifold in a three-dimensional situation, if you now do a projection onto any linear domain, you usually have a problem finding. So if you do a PCA here, you will not get a nice separation between the colors.
Mm-hmm.
It only works if you take a smart embedding like t-SNE or any locally linear embedding or something. You just try a PCA and you omit one of the three dimensions you project onto a plane, then this will not work. Well, maybe there's it's gonna be hard at least.
In general, you like when you compress information.
Yeah, you lose.
You basically try to retain what's useful for you, and you try to lose what's not useful.
Exactly. Yeah. And in this example, the useful information is the gradient from red over yellow to blue, right? And you might lose that information if you just project onto one axis, for example, or on one of the XY plane, for example.
So that's where, that's where we need more labels. Okay, these labels should tell us what are the meaningful informations, so that we can train our dimensionality reduction to retain that information.
Yes, that sounds interesting.
Even the sound generation team also asking for information about what each dimension represents. I mean, it will be much more helpful for them. This is their comment.
But
okay, so disentanglement is a nice to have, if I understand it correctly. Right?
Yeah, I think so.
Like they want an embedding, and it would be better if every single dimension of the embedding had a specific interpretation.
Yes.
Right?
Yes.
But it's not required.
It's not required, but it will be helpful.
Okay, so.
Oh yeah. I mean, if you have two dimensions which are interesting, and you provide only the sum and the difference of those two dimensions, and maybe it's no longer that interpretable, but you only need one layer in the neural network to disentangle that. The question is whether the learning is going to find that disentanglement.
Exactly.
So if we can provide a disentanglement by ourselves, then of course that's nice. But if not, they will just try to give it to the neural network and let it figure it out themselves.
Yeah.
We still need to know which information to retain, like whether we impose disentanglement or we just try to retain information, because we are compressing information.
Oh, in the dimension reduction step, you mean?
Like, for example, we would need some kind of information related to the to the instrument once we reduce the embedding of that instrument.
So this is why I like your approach. If we have sentences and we would like to find out which dimensions contain the information about whether an instrument is a wind instrument or, I don't know, a brass instrument, and we just feed, we take sentences with only wind instruments and sentences with only brass instruments, and we see in which dimensions the output embedding is changing. And those are the dimensions that we would have to retain to have the distinction between brass and wind instruments, for example.
Yeah, that makes sense.
Like we could just train some fully connected layers to classify between brass or strings,
that's also
or whatever.
That's also possible, yes.
And we could do that also on words and not on sentences. So we could use that also in the case of entity extraction.
Yes.
The point is that we need that information. We need to know that guitar is a string instrument.
Yeah.
Yes.
And for every other information that they want, if they provide us the label, we will extract it, basically.
Yeah, that seems a bit lazy, but it's, of course, if that is the case, then that's easy. Yeah, then we should do it, and maybe we should prepare for that as well. Maybe we should set up this training pipeline for one such aspect, at least for now.
I mean, less lazy and more cool way to do it, like for example with autoencoders and disentanglement, like in these two papers here.
Yeah.
And but like this is better, like maybe it gives better results, but the approach is the same. You have informations and you train your model towards those.
Yeah. Yes.
Yes. I think we had a lot of discussion today.
Yeah. Yeah.
So
yeah,
are we?
Yeah, Mirko. You're saying something?
Yeah, like should we like wrap up? Make like say what we got so far?
We should try to summarize, yes.
Yeah, summarize. Thank you. I was trying to find that exact word. So I think we have two possible approaches. Mm-hmm. One is from like embedding a sentence, and the other one is extracting entities.
Yeah.
Okay. And from both, we get highly dimensional arrays. Then, based on additional information given on our sentences, we can apply dimensionality reduction and get to a lower dimensional array, training towards those informations in order to retain them. Mm-hmm. Did I miss something?
One thing that we haven't even spoken about explicitly, but if we find a word embedding for instruments that makes sense, that would help, of course. Yes. So if we find a 5-dimensional embedding where all similarly sounding instruments are clustered together, then we would have that information already, and we could just pass on those 5 dimensions as part of whatever else we provide, and those would certainly be useful for...
How do we find that?
Yeah, that's a separate question. We haven't really talked about it, but if we have a categorization information, for example, of string instrument or brass instrument and so on, that could help, right? Or as we talked about, if we have examples of these instruments sounding like audio examples, and we find a similarity of those audio examples, and we can also add this similarity information. Yeah, that would also somehow work.
Yeah. It's still adding informations to our dataset, basically,
exactly.
that we can use on dimensionality reduction.
Exactly, but it's explicit info. I mean, you don't even have to reduce that type of information anymore. If you know it's so important the information in it is really intuitive for humans, and you don't have to do any compression anymore on that. We are worrying about compression because we have 784 dimensions or whatever from BERT, and BERT tries to use grammar and has a billion different concepts in mind, and we only need our music information. But if we have specific musically relevant information, then we don't have to compress that anymore.
Yes, but the point is that how we're gonna do it?
That's the case of the entity extraction, though. Like, we just extract the keywords that we need.
But then
the context doesn't matter.
But then is a cello, is it closer to a violin or closer to a drum? How do you find out?
That's where the word to vec comes in place. Like,
okay.
you take
that we should test, because I'm seriously skeptical whether we will find that a drum is closer to another drum than it is to a violin or to a string instrument.
If it is not, we could hope to achieve that by retraining the word to vec on the corpus of the like a corpus that talks about music.
So how about this? Shall we, for the next week, we could try to formulate such testing tasks, because we now have the word embeddings, at least for certain. We have lots of embeddings already, right? We did the performance tests. Now we should figure out whether instruments that we have and that we know sound similarly, whether they are at least roughly clustered closely in the embedding space.
Yeah, we can try it out.
Okay, the models that at least that I tried are all sentence embedders.
Yeah, but then you generate sentences as you've demonstrated with instruments that sound similar and with instrument that sounds clearly dissimilar. And maybe you can also have some like hard adjectives and soft adjectives or something like that, and make two groups. And then we see whether the clustering of the sentence embeddings in the end, at least in some way, still contains that information.
But how do you check if the two embeddings are much closer?
I would take a cosine similarity. Do you have any other suggestions?
Yeah, I mean, that is the most.
There are models that are explicitly trained through cosine similarity. So we could start from those.
So one problem, of course, is the curse of dimensionality. If we have 128 dimensions and we take a means and Euclidean distance, I'm not sure whether we will see anything. This could be just because of the dimensionality.
Mm-hmm.
I know.
Yeah.
But let's try out, right? Because as long as we don't find that, as long as we don't see that string instruments are closer together than to wood instruments, like the within cluster variance is smaller than the between cluster variance.
But
I'm skeptical, sort of, whether we actually captured something relevant.
The point is that we want that, like we want to group them together.
Yes.
So why don't we just formulate a training task that achieves it?
Yeah, but up to now, we always said Word2Vec does that for us, or BERT does that for us. BERT knows about these things. And we should test it if we
exactly.
could do that.
Yeah,
See,
we know that BERT does it, but actually it does or not, we need to test it. If it able to group the things together, then it's fine. Otherwise, we have to look for other options.
Yeah. And I also agree that we should try BERT because it's said to be the best model out there, but it's just not clear whether that's also the case for musical instruments.
Yeah, I mean, anything we need to try it out and check.
Yeah.
I think that depends on the dataset, though.
Yeah.
Mirko, I think this could be a good task for the two of us to pursue now, because we have the word embeddings, you have the code, and we have the performance test. I mean, okay, we don't need performance, but we need the embeddings.
Well, see, basically this becomes like a new metric into the embedding tools.
Mm-hmm.
We still need to generate the data set. This is a task on itself.
Yeah, I mean, about that part, we can talk with the data generation team how they're going with that, because last time.
But even if we just take all like string instruments and all, I don't know, percussion instruments, and we generate the sentences, I mean, yeah, that would already be a first test.
I think we need to figure out exactly what we're trying to achieve. Like, if we want to see if an instrument like a guitar is very close to I don't know, a piano, we just need 2 sentences.
Mm-hmm.
Of course, it would be like more robust if we had more sentences. Yeah, for robustness, we still need to generate more.
We need, that's why we need your code there. We need to see whether the formulation of what's going on in the sentence, whether that completely destroys this signal or not. Even if it's there, if we just use the word embedding for guitar and piano.
Because in that in that sense, basically, we wouldn't need the entity extraction part, because the context wouldn't matter anyway.
So for Word2Vec, I agree. This is a nice first test. We just take the word embedding of Word2Vec and see whether different classes of instruments cluster similarly.
That's also easy.
Yeah, that is the first test we can take. And one more idea we talked about is the taking the embedding of the entire sentence, and as well as the taking the embedding of the important entities, and checking out which one works well.
Yeah.
So yeah,
I mean, definitely, I don't know, but so how do you mean which works better? How do you mean that? How do you measure?
I mean, we can check the similarity. No, we can't even check the similarity, right? Yeah, we need to find a way how the representation is good in the lower dimension.
Yeah, exactly.
Yeah.
So do we have to do a clustering somehow? We have to do a k-means clustering on those word embeddings and see whether piano or like guitars are clustering together somehow, or?
Yeah, that also a good idea. So we give for the 2 sentences, we can see how close the words are, the embeddings are clustered together.
Yeah.
That is one of the measure we can do.
So you take the 10 nearest neighbors of a few instruments and see whether those instruments are somehow similar instruments, or whether the next few instruments are just completely different instruments.
Yeah, true.
So let's take the 10 closest instruments and not the 10 closest words, and then see whether among those instruments, they are somehow related.
But anyway, anyhow, we need to make a sentence out of it, right? For the each instrument.
Why?
Because our main task is comparing the embeddings of the entire sentence as well as only the embedding of a.
Yeah, that's correct. My hunch is that words are simpler than the sentences. I believe the sentence around it is just going to be noise.
I mean, it's a 3 task actually. First task is to only take the words, the instrument which are much more closer, and checking in the lower dimension how close they are. And if they are close, then the next step is going with the only that wording as well as sentence.
Yes, and that I agree. Yes. So if all works very well and the instruments themselves cluster very nicely, then we already have. Then we only need to do the instrument extraction, and we already have relevant information. And if that's not the case, then then we have to see how it works with the full sentence embeddings.
Yeah, exactly. Yes. So I'll be left with something.
I can be picky and say, give me a guitar-like organ, and then and of course that won't.
Oh, you're right.
Right. So these cases, I mean, we have to define in which situations our system has to work well.
Yeah. True.
In that case, you have guitar, which is an instrument, but it's used more as an adjective.
Guitar, yeah.
No, like this is the example that you were looking for before.
No, I don't think so, because these are made up examples that are not relevant for our application.
Okay. Why?
I believe.
Why are they not relevant though?
I mean, whoever uses a guitar-like organ is stupid themselves. Then I don't.
Well, okay. Okay, you got the point there.
Nice.
Okay, but I think let's generate these word2vec embeddings of instruments and analyze that data. So we provide that data set. I think that's the first task. And then we analyze it both with the full sentence, in the full sentence version, and in the simple embedding set.
So can we get the list that data sets, I think, list of words that they are making, so that we can use that to generate the data set?
Yeah.
Like where is that? Like where can I find it?
It's the same document which has been shared before, which the Shubham has used to train the model, right, to generate the entities. In the same file, they are updating it.
Anush, could you just put the link in our chat?
Yeah, sure. I think I have to check it, but yeah, give me a second.
Yeah, just for later.
Yeah.
And then also, if you want to have a look at the code we have so far, if you also want to do using embeddings and things, then feel free to just tell us.
Yeah, sure.
I saw the Oliver update. Did you see that on Slack?
Oh, no.
So it basically says focus first on guitar sounds only.
Okay.
So this basically reduces our.
What does that mean?
Don't take these sentences.
That's a good question.
I think don't take the sentences other than guitar. Start with only guitar. But it doesn't make sense, right? Because the model embedding will change once the instrument comes in. But I don't know exactly what he meant there.
I interpret him that way, that so we have the adjectives that are important first somehow. we take the guitar is flexible, it can do anything, and we would like to find out whether a, I don't know, screeching guitar and a soft guitar, whether we can actually
Well,
detect
there is also
in
classical and electric that are kind of two. They are kind of two different
yes.
instruments.
Yeah. Yes. Yes.
Another question that I have is that, do we take into account different physical guitars, like, I don't know, Epiphone, rather than like other models of guitars?
You may try.
I don't think so. Like that would be very, very specific.
Yeah, right. I don't think he means that. I think he means we are trying to understand the sentences that are given to us based on the fact that the user knows that it's going to be a guitar that plays that sound. So we don't really care what type of guitar it is, but we care about how the guitar is played. And we should be able to disentangle different sound styles of guitars.
Well, in this case, I need like an expert, a more expert person that knows about guitars, because one thing is knowing that a cello sounds different than a piano, and another thing is that like an electric guitar with a certain, I don't know, distortion sounds different than something else. Okay.
I think, but you can very easily go to one of our options and tell him you 20 adjectives of how a guitar can sound.
But I also need to know how related are those adjectives in order to cluster them together and do what we said.
Because you don't have the combinatorics anymore. If you only have one adjective and you get 20 different values, then you can generate 20 different sentences, essentially, not much more.
Yeah, but then how do we do the rest? Like we wanted to like take an embedding, take the neighbors, and see if those neighbors made sense. But they make sense if they are closer when they need to be closer. So I need to know in advance if they are close or not.
Yes.
I need this information from someone who knows it, basically.
Yes.
So I have posted the link in the Slack group. So every instruments.
Yeah. Yeah. Oh, yeah.
Yeah.
So
I think the common pattern data set with the guitar thing in mind.
That's still for all the examples, this data set. It's not just guitar.
Yeah.
But we have no clue whether a prompt didgeridoo sounds similar to a weak bagpipe, or a rude oboe sounds whatever, you know? There's no structure to learn from in these sentences. I think we just take Word2Vec. In Word2Vec you hopefully have common adjectives like a sharp and a, I don't know, a loud. They should be closer than a soft and whatever, you know?
Oh, okay. So basically, if we reduce to guitar, we say, okay, the instrument is guitar. Let's focus on
the adjectives, and we let's look at Word2Vec adjective embeddings and see whether they cluster in a useful way somehow. That sounds that we imagine on a weak guitar, and just looking at weak, whether this sounds similar to a, I don't know, dramatic guitar or I don't know, a sleeping guitar, and then find out how they relate and whether they cluster in a meaningful way.
So what if we produce these clusters and then we evaluate them with a person from the sound generation group, or like someone who can actually critically evaluate them.
Sure. But it's not going to be so hard. I mean, if you take the 5 closest adjectives to, I don't know, you can see it. I mean, if we are successful, then we see it ourselves that these adjectives are really more similar than that. Should work actually.
Okay.
Let's make a large list of adjectives. Take the ones that are already here, and a few more, I guess, and then do a clustering analysis.
Yeah, we can do that.
Does anyone have experience in analyzing clustering quality?
No.
I can set up a nearest neighbor search very easily. But
yeah, sure.
I agree with a KD tree. You get that in 4 lines of code.
Yeah, of course.
But apart from that, I don't know. I should study some theory.
I think in computer vision there is a lot of clustering algorithm which checks for the closeness. I guess we can.
Clustering produces clusters, and it uses distance metrics to do that. But the distance metrics, that's usually an input to clustering algorithms.
Yes.
So we should just take like a scikit-learn clustering, generic clustering algorithm.
KD3 sounds nice for me if they have like Euclidean distance and I don't know, a Manhattan distance or cosine distance or whatever there is.
It's a special distance, but the point is that they do not produce clusters.
No, but that's not what we want. We just need to see whether the closest neighbors of these adjectives are similar or similar enough in our sense.
Yeah, we need to measure it.
The closeness, let's say, in the KD trees is computed in a very specific way. They basically take into account a dimension after the other, and they split.
Yeah, but KD3, you need KD3 if you have thousands of examples. For these 100 examples, we can just compute all the, what is it, 100 times 50, 5,000 different pairs of examples that we have.
I have one question. So how do we, first thing we need to generate the embeddings, but the embeddings we are talking about is generating using Word2Vec. But Word2Vec is been not already trained on the data set we are looking, right? We don't have that data set.
We don't know which words are in there.
Yeah. So for
actually, we did something similar in another project in my company. We had basically this sentence, okay, and the expected sentences that the sentences that we expected to be close to that, okay. And we tested the embedding models. We needed to test FICE on the recall of their result towards what we were expecting. So basically, if given a sentence, we would get back, let's say, 5 other sentences, and 4 of those were the sentences that we expected, okay. The performance of that was 75%, okay. So we could use like a similar approach to test our embedding models and to choose the one that it's more performant for our case.
Okay.
Yeah.
I haven't understood the methodology yet, but it sounds interesting.
The only thing we need is that we need to formulate before what's close, what adjectives are close to a certain adjective and what are far.
We don't know.
We like to do that. We need to know it in advance.
Okay.
Like maybe we could take like obviously close adjective and obviously different adjectives. We could come up with that idea.
Yes.
Yeah.
So if we build pairs of adjectives that are close and those pairs that are far apart, then we can test whether whatever similarity metric we use on pairs of such adjectives, whether they also see this distinction between far away adjectives and close adjectives.
Yeah, it would be simpler if we just like made two groups of adjectives which are very distinct, and so that we would test if, like, taking one adjective from a group, the close ones are within the same group.
I don't think that exists. I think we have to build pairs of similar adjectives and dissimilar adjectives. But okay, I don't know.
Yeah, I'm starting to complicate things. Like
no, if that existed, that would be very nice. But I think we don't have a bipartite structure. We have a very complex interrelationship between all these adjectives. Some are closer, some are less, and so on. This is not going to be. Some adjectives are either close or far away from all the others.
Because, like, I am afraid of, like, bias. I don't know. Like, once we put an adjective inside a model, we get the embeddings, and basically, given an embedding, we take the neighbors. Okay.
Yeah.
How do we say that we are happy with these neighbors or we are not happy with these neighbors?
We give them to the musicians and ask them whether they would also see it that way.
Okay, so basically the whole approach I said before, it doesn't work in this case because we would need the information from the musician in advance, but that's at the end of the pipeline.
I think that's asking a lot.
Yeah. No, that's not possible. So okay, so we basically just produce these results and we'll have them to evaluate them.
Maybe we find what's the word for an antagonistic, like contrary adjectives. Maybe we find a list of those, of pairs of very dissimilar and very similar adjectives.
Well, like this has various interpretations.
Yeah.
For example, you could say that bright and dark are opposite, but they are talking about light. So they are similar in that sense.
So it will be grouped closely in the cluster.
Know. Yeah.
So that's why, that's the point of the dimensionality. Like you have more than one dimension.
But there's in our context there's a clear. I believe it's clear that bright and dark are not similar adjectives when it comes to describing sounds.
Yeah,
but
according to sound, it is not similar. But when we go for the lower dimensions or the embeddings, it matches them as very close, dark and the small.
Yes, and then we should not take that projection.
Yeah.
Because, for example, if you take bright, dark, and distorted is very different from bright and dark in the sense that it belongs to another context.
Yes.
So
But
I don't know.
But if we are talking about describing a sound, and we get texts about sound descriptions, then for each of these words you will, I mean, we're just evaluating the word embeddings, and definitely distorted can be close to bright or it can be close to dark. I don't know, I don't care, but I care about bright and dark being far away, sort of, I guess. Or like bright being closer to, I don't know, dark being closer to black and bright being closer to white or something like that. I don't know. Definitely pairs where I'm indifferent whether they can be close together or not.
So from what I'm understanding now, we don't have a clear idea of what is similar or not. We could suppose some rules, but I think that at this point we should just have the sound generation or music group to evaluate this.
Yeah, but I believe
I think they can like reason more.
Sure, but I believe there are pairs of adjectives for which there's a very clear answer from the music group, and a lot of pairs where there's no clear answer, and you know that there's no clear answer.
Yeah.
And you can also predict that, right? You can predict that an eventual and a kind violin are, I don't know. That's just you don't have to predict one of the two extreme, that they are opposites or similar. There's no, you don't have to evaluate that because it's just sort of clear that it doesn't make sense.
Yeah, that it depends on if it's an information that you want to carry on, or if you don't care about.
Yeah.
And that's where a labeling of some sort would come into place.
Yeah. Yeah. Sure.
Yes.
So I think we should start from like generating these nearest neighbors, and basically producing these results and have the music group or some other group to evaluate them.
Yep.
So in order to do that,
yes, sounds. But I think in the first iteration, they will say that these two adjectives, I can't say whether they are close or far away. There will be many such examples. And maybe the first iteration would be just to find pairs of adjectives that actually are somehow related to each other.
So how do we find those pairs?
So for example, we could take the Word2Vec closest friends and see whether they are really close also for the musicians. That you can do, or you can try, I mean, yeah. I don't know how to find antagonists, adjectives that are very far away. There are many that are far away from any given embedding. We cannot easily find the ones that have to be far away.
I think we can try with the simple sentences and work upon it once, if it in the cluster it, if it's fine, if it's very close. These all are the edge cases,
yeah.
right?
Yeah, right.
Yeah.
So the strategy would be to let the musicians identify pairs of close adjectives, and then we compare whether we can distinguish between being close or not being close. So any example that is a classifier should just tell us whether these adjectives are roughly close or they are not.
Yeah.
And if we can somehow match this reasonably well, then maybe we have learned something about the Word2Vec structure.
Yes.
Are you talking about training a classifier?
Word to vec classifier and generating the embeddings and checking how the classifier classify them, how close they are, and how the music group give the feedback at how they are close. Suppose if you give
how close is a regression task? Whether they are close or not is a classification task.
Yeah.
I don't understand if we are trying to take the information of how close they are from a pre-trained model and then compare it to what we know, of if we are training a model in order to respect what we like, the distance that we give.
Yeah. For the second possibility, people would have to label. In the first possibility, if we're successful, then they only have to check that a decent amount of examples works well.
Okay, so here's another idea. What if for every model we generate like, I don't know, 10 pairs, 10 couple of words. Like for every word, we just take the closest neighbor, okay? Yeah. And then we give these couples to another group, and we ask them to rate how close they are, like in a scale from 0 to 5, I don't know. And so that in that way we can see which model achieves the highest score.
Yes.
Do you know WordNet?
No.
WordNet, as far as I understand, they have similarity metrics for adjectives, especially. So it's essentially non-artificial intelligence. It's just a data set of adjectives and words and how they relate to each other. How words. I think it's quite manual. It was built. I don't know how it was built precisely, but I think there we will find some data set that has what we need if we. We will find similar adjectives. I think that we can generate.
But those are similar in general. We are trying to find similarity in the context of guitars.
I believe they will be sort of similar and not very different from the context of guitars and the general context. I don't see a large. But you might be right. I don't know.
Oh. So what if we just ask if the similarity that WordNet has is actually viable? Like, because if we just need the similarity that WordNet provides, why don't we just use that? If we find out that that's not
true.
That's not the case, then we will need neural networks or some sort of fine-tuning.
Good point. Yeah.
Mm-hmm. Yep.
Let's look at it.
Yes.
Let's wrap up.
Yep. It's been 8:14. Yeah, anyway, I will post this recording. I think I can't post the video. It's very long. I think I'll extract the audio.
Maybe we should assign activities. I don't know.
Yes.
Yeah. So Beat, you told you are interested in word embeddings, right? And you and Mirko will be working together to generate the word embeddings and how well it will work. But before that, we need to go check for the similarity between these sentences.
Yeah, I mean, I think we should now work on this data set of similar words. I think that's, but.
Yeah, I mean, if you're interested, you can take that. Then I can take something else.
Yeah.
So
what do you want to do? I'm not so sure about where you are in
yeah, I mean,
your
I will check out the finding the generating the embeddings for the sentences as well as the individual words, and checking how the embeddings varies, how close they are,
that's nice. Yeah.
how close they are, how far they are. I think I'll focus on that. So
Okay.
yeah,
Okay. Yeah.
Mirko.
Could you do it in 2 stages? Could you first generate a data set of word embeddings, and then I think the analysis will be, we will have to repeat it for different, different tasks, different models, and so on. There you probably have to work with Mirko then to find,
Yeah, I mean, I
to
have to,
evaluate it.
yeah,
Word embedding.
yes, for generating the sentences, I think I will work with Mirko. I will take that data set and I'll see how well the embeddings will vary.
Okay, so on my side, I should basically work on the generation of this data set. Is that correct?
Yes.
And is there someone who will check out WordNet?
I was just thinking of this, yeah, but it's similar to your task. So maybe we are again quite close. I would look, if that's okay, I would look at WordNet and try to find pairs of similar words and whatever functionality WordNet offers. Maybe also antagonistic adjectives or something like that.
So I think if Humberto also wanted to look into it, I think he can look in that.
It's fine for me, yeah. Humberto, are you there?
Humberto?
Hello, I'm here.
Ah!
Hello.
Hi.
You were very silent. But
yes, I was listening.
Did you say you wanted to look into WordNet? I should ask.
And what? Sorry.
What would you like to do?
What do you want? I mean, there is one task.
Which are the options? Or how like me to?
So Beat was talking about the WordNet, where we'll find the similarity, right, between the adjectives.
There's one task of finding pairs of adjectives that are either similar or contradictory somehow.
So I think if Beat has this resource, I think he can send that to Humberto and he can start looking into it. But Beat, if you understand properly, I think you can explain it to Humberto. To me,
But I'm out of work.
You'll be working on the embeddings, right?
Which ones?
Yeah. So there.
But yeah, I mean, I can coordinate with Mirko if that's. But currently, I don't see a clear task there.
I mean, I think Mirko also talked about one topic where we can find the similarity between the words, right, and sentences as well. That is KD tree, as well as one more thing he suggested.
Oh, yeah.
I mean, you can look into that as well.
Okay. So let's just look at finding the k nearest neighbors of word embedding. Yeah, sure.
Yeah. Then and I mean, you can choose if you want to do that, or WordNet looking the closeness fine. Using, or Humberto can work on that.
Yeah. No, that to me either is fine. Humberto, would you rather like to find the k nearest neighbors of some word embeddings, or look into WordNet and what it can offer to give us pairs of similar or dissimilar adjectives?
Okay, I can look at WordNet.
Okay, cool.
So we have the task right now, I guess.
I think so.
Yeah.
I think so, yeah.
Yeah.
And Mirko, you are. What are we? What are you doing again?
So Mirko will be generating the sentences for me.
Oh yeah. Okay. Cool.
To find the how close the embeddings are. But how close the embeddings are, that I will be working on. So Mirko will be working with me for generating the sentences, as well as I think he needs the inputs from the music group as well, I guess.
What's the second part you said?
You need some feedback from the music generation team, right? What kind of acoustic guitar they're talking about. I mean, how we can, suppose they have given like acoustic guitar brands, Martin, Taylor, Gibson, where we can place that in a sentence. So you need that information, right?
Okay, yeah. The information was that if we need to place it in a sentence, but yeah, the music group, right?
Yes.
Okay.
Yeah, I think Jacob and Lucas, I think they are the one you can contact with.
Lucas and Jacob?
Yes. Music generation is coordinated by Jacob.
Okay.
Yeah.
Manoj, I'm still not quite clear what's the difference between our tasks. If you're looking at similar word-to-vec embedding, words with a similar word-to-vec embeddings, what is the difference to finding the k-nearest neighbors to each word embedding?
So I'll be looking at only the words and as well as sentences. So how the embeddings of those two are close together.
Oh, you compare sentence embeddings and their corresponding word embeddings. Yes. of the adjective.
Yes.
Okay, cool.
Yeah.
Yeah, that's good. That's good. Okay. Then I'm looking more into the structure of the word-to-vec embeddings, like how close what are the nearest neighbors, whether they make sense.
Yeah, if you are able to find, is there any other parameter we can check for the closeness of a vector in a low dimension?
What parameter?
So you can try to check for, like in computer vision also, there are a lot of approaches which checks the closeness of vectors or embeddings.
Yes, of course. Yes,
yeah, you can try that.
I will try different similarity metrics.
Yeah, and Humberto will be working on the WordNet. Yeah,
sounds nice.
Yes, I think we have.
Yay, we're done.
It's been 3 hours, 3.5.
Imagine Oliver when he will see that he needs to listen to all this.
That's precisely what I'm trying to say. Maybe we do. Manoj, could you just put a few lines into the Slack chat?
Yeah, sure. Anyway, I'm gonna convert this one into audio and post it. We listen.
Yeah, okay, yeah. It's gonna be a nightmare if you have to listen to all of this. But we know what to do, and maybe you can talk to him, or I don't know.
Yeah, sure. I'll talk to him, and I will update in the group, and also Shubham and Paras. I think Oliver also will take some topic, I guess, to work on.
Yeah.
I'll discuss with him.
At this point, I think I will report the second approach, the one based on the entity extraction on the same document, so that we have both, and like Oliver can just look at that, maybe.
Yeah. True.
Okay,
then we'll wrap it up. See you guys, it's good talking.
Nice.
Yeah. Bye.
Bye.